Hello there, my name is Aaron Gardner. I'm doing student video number 3 for MAT-271 calculus. So the first thing I want to look at right here is you see this continuous slope. Sorry, I didn't mark there. I say continuous slope as in it is constant. That slope will be -1/2 because it is rise over run. So because of that, this will be -1/2. And then what we're going to want to do is graph on the derivative graph down here from the interval -6 to -4. There's a slope of -1/2. So you look and you see right there, right there. That is a constant interval. Then after that, you're going to see that up here is a constant interval of no slope. So that is going to go from -4 to -1. That will be right here. Okay. So right here is where it starts to get a little difficult. But what you're going to see is that, so in this interval right here, there's a slope of 2. So but it is going to get progressively smaller and smaller. We see that the slope ends up zeroing out right here at 2, 3. So because of that, we're going to go ahead and mark right here where the slope turns to 0. And then so we know that is the instantaneous slope value. Know that one for sure. And then because it's a parabola, it's going to be moving like so through it, because it's almost a negative cubic function, so to say, in that there is a positive slope that gets progressively closer to 0, and then once you hit it here, it's almost the equivalent of the backside of a normal upside down parabola of a negative quadratic function. So with that, we're going to kind of be able to from there roughly sketch out using points using points of, what's the word I'm looking for? Important points. So we'll see that, if there's a slope of -2 between this interval right here, we'll want to be starting right up there anyways. And then as we move from 0 to 2, there's a slope of 1/2. So we're gonna kind of hit this in the middle right here anyways, but once again we have to keep that shape. So the first half of this is that we will have to go ahead and kind of start to curve it. Now as it hits 0 on here, it's going to kind of be passing through this slope of 1, and then it's going to go it's going to be following like that. Actually, I think I did that a little wrong. So it's going to be more, yeah, there we go. Then it's going to meet right there. So I didn't mean to shoot that out from the side. I'm sorry, please discard that. It's going to be coming out from the underside more. So I'll make this bold just so it sticks out a little more. And then from there, you're almost going to want to mirror it. But we know that the slope becomes forever continuous before it hits 6. But as it gets right here to the point of 5, there it's going to be the same. That there's a 1/2 slope right here. There's a 1/2 slope up until right about here. And then it's going to be down to -1/2 slope right there. And then it's going to hit kind of -2 right around this 5 range. So using that, now we're also going to kind of mirror this in a way where it shoots. Okay, that's not brilliant, but here, so okay, it's not pretty, but you get the point right here. So it's going to kind of drop through like a quadratic function. Once again, this doesn't look great. So I'm really going to try and embolden this. So you're going to be able to see that slope will get progressively bigger as it moves on and on and on. So yeah, once again, not pretty, but using points, you can kind of tell right there. Thank you.